Most RAG apps fail before the model even starts talking.
Exactly. People blame the LLM, but a lot of the damage happens upstream, in retrieval, chunking, ranking, and grounding.
So, when people say they are evaluating a RAG system, what are they actually evaluating?
RAG evaluation means measuring whether the system finds the right evidence and then uses that evidence to produce a useful, faithful answer. It is not one score. It is a pipeline check.
That sounds obvious, but teams still wave around a single answer score like it proves everything.
And that is the trap. A polished answer can hide terrible retrieval, and weak wording can hide good retrieval. If you do not separate those, you cannot debug anything.
Give me a concrete case.
Say you build an internal support bot for your company handbook. The user asks, "What is the parental leave policy for contractors?" If retrieval pulls the full-time employee page instead of the contractor policy, the model may answer smoothly and confidently, but the system still failed.
So the answer can sound great and still be operationally dangerous.
Right. In RAG, correctness is not just about language quality. It is about whether the answer is supported by the right source material.
Let us split that cleanly. What is answer quality versus retrieval quality?
Retrieval quality asks, did we fetch the relevant chunks, documents, or passages for this question? Answer quality asks, given those retrieved items, did the model answer accurately, completely, clearly, and without inventing facts?
So retrieval is about evidence selection. Answer quality is about evidence use.
Perfect. Retrieval quality is often measured with things like recall at K, precision at K, hit rate, ranking quality, or whether the goal document appeared in context at all. Answer quality is more about faithfulness, correctness, completeness, and task usefulness.
Here is the tension. If I only grade final answers, I might miss a retrieval problem. But if I only grade retrieval, I might miss that the model still mangles good evidence.
Exactly. Two different failure modes, two different owners, two different fixes. Retrieval issues might call for better chunking, metadata filters, embeddings, re-ranking, or query rewriting. Answer issues might call for prompt changes, citation rules, context formatting, or a different generation model.
Let us do another example, but this time, something with real stakes.
Imagine a legal research assistant. A user asks whether a contract clause is enforceable in California. Retrieval brings back a federal case summary and an outdated blog post, but misses the recent California appellate ruling. The model gives a balanced, articulate answer. It still failed because the key authority never entered the context.
That is the kind of mistake that loses trust fast.
Yes, the winner is not the team with the flashiest demo. It is the team that can prove the system retrieves the right evidence under pressure and degrades safely when it cannot.
How do programmers actually evaluate this without building a giant academic benchmark?
Start with a small, curated test set. Real user questions, expected source documents, and what a good answer should contain. Then run two evaluations. First, retrieval only. Did the expected evidence show up high enough in the ranked list? Second, answer only. Was the final response correct and grounded in the retrieved context?
Small meaning what? Like 20 questions?
Even 20 to 50 high-value questions can expose ugly patterns. You are not trying to impress a paper reviewer. You are trying to catch failures that matter in production.
What kind of patterns show up?
For example, questions with acronyms may retrieve the wrong domain. Multi-hop questions may pull one needed document, but miss the second. Policy questions may retrieve stale versions. Long chunks may bury the answer, even when the right document is technically present.
So, if a team says, our bot got an answer score of 85%, your next question is?
How much of that is retrieval success, and how much is the model compensating? Also, where does it fail? Misses, wrong ranking, stale docs, unsupported claims, or incomplete synthesis.
Because those failures change the roadmap.
Exactly. Good RAG evaluation turns a vague feeling of unreliability into an engineering map. It tells you whether to fix indexing, ranking, prompts, citations, or abstention behavior.
And if you skip that step,
then you ship a system that sounds smarter than it is, and the first serious user will find the gap. In RAG, the best answer is only as strong as the evidence it can actually reach.